are. Thank you, anonymous attendee, for reminding us to do that. Okay, keeping going. In terms of Homerton, so not just colleges in general, this is our college. You can see these really lovely pictures. And I mean, it looks even better than this today because there are no clouds in the sky. But we've got some really lovely old bits to our college. You can see a beautiful building here. This round window here is the Great Hall, which used to be our dining hall, but it's now used for all sorts of things. So music, concerts, drinks, receptions, table tennis, whole range of things. And then we've got much newer buildings. So this picture over here is our new dining hall, which really does look very massive in this picture. And it is very large, but it's a beautiful light building to sit in and to eat in. And I point these two buildings out because I think the buildings are old and new, but Homerton and the ethos of Homerton kind of encapsulates that as well, because we are the newest college. We had our charter dinner at the weekend, which was it's like a birthday celebration for the college, which was a really nice evening. But we are a new college. That doesn't mean that we don't have all of those same really wonderful traditions that Cambridge has. Our Homerton students will graduate at Senate House, just as everyone else will. We have formal halls. All of those things are there, but we're also really forward thinking. And one of the ways in which I think that's particularly, or I'm particularly proud of at Homerton, is in the teaching and how the teaching and learning happens, and how we're always thinking about, well, how can I make sure this is the best learning experience for the students that we have here? We do have a really big and really diverse college community. We've got a large number of undergrads and a large number of postgrads, and they together make up our college community. The fact that we have a large and diverse cohort means that it's generally pretty easy to find your people within the college. And because there's enough people, everyone kind of finds the place they belong, and it might take a little while, but it'll be there somewhere. And as a college, and I kind of mean that in the broadest sense, but this is certainly something, I've got a slide in a minute that has Simon on it, who's our principal, certainly something that comes right from him as the principal, how much we value that diversity. And we value diversity in all sorts of ways, but I think with particular relevance in this conversation, diversity in educational background. So we have people coming to us from all sorts of schools, from all sorts of parts of the world, and from all sorts of examination systems. And each of those people brings something different, but brings it into an academic world where it adds value. And so that diversity is something that we're really, really proud of. The other thing that I want to mention whilst we're on here is the Changemakers program. You've got a little logo for it up here. But this is a program that speaks to point 3 here, because the college is committed not only to academic excellence, that is, it's Cambridge, academic excellence is something that we're kind of all about, but also to making sure that the people who come here and study here and work here really are thinking about, well, actually, how can I use this knowledge? How can I use this education to make a difference in the world, have a positive impact on the world? And this is something, again, and I'm going to skip to the next slide. This is something that Simon speaks to at many of the dinners we have. And again, Kira, I'm sure you've heard this at points. And he talks about this in terms of a responsibility. It's not, coming to Cambridge is an incredible opportunity, but it's also a responsibility. And I think the fact that that thread comes right through college means that we really are living that desire to make a positive impact in the world. That's Simon standing outside the door of the Great Hall. He sometimes does look like this and dresses up very smartly for occasions. You'll also find him around college just chatting to whoever he comes across, playing table tennis, talking to the students at lunchtime, joining in with whatever's going on. And I think it's really lovely for us that that's such an integral part of the college. There are some other kind of points about college here that's worth making. We are very close to the train station. We're also very close to all the departments really, because Cambridge is a very small place. And if you have a bike or get on the bus, it's really not that far to get to any of the departments that you're working in. We do have really beautiful gardens and grounds. We're so lucky to be in an area of Cambridge where we can have a little bit more space. And so we've got a pond and an orchard, and we've got sports fields on site and all of these sorts of things. So it makes it a really lovely place to live and to work. I feel really lucky coming in the mornings. The gardeners do such a great job. We've got really great facilities. So I've mentioned some of those already. And we have some of the cheapest student accommodation in Cambridge, which is always a good thing. But perhaps even more importantly, look, it now boasts more ensuite rooms with internet access than any other college in Cambridge. We need to check that that is still true, but it certainly was true when we wrote this presentation. It's also worth mentioning, because we know that applying to university can be financially quite a tricky thing to think about. And so there are various forms of financial support available. And if that's something that is really important for you to engage with in order to allow you to study, please do get in touch with the admissions office and they can give you some more details about the things that might exist. So I'm just going to finish off by thinking about what happens next if you are interested in applying to Cambridge. First of all, choose your course. You're here for maths, probably it's going to be maths, but we may have people here who are interested in other things as well, and that's great. Then choose a college or an open application. Again, if you choose an open application, you just get kind of distributed and then you're treated just like a normal applicant. We'd obviously recommend coming to look at Homerton and seeing if that feels like a place that you belong, but many other colleges are available. You need to check on admissions test arrangements, and I'm sure, again, Anthony will talk about this, and then apply through UCAS. There is an earlier deadline for Cambridge. The deadline here is the 15th of October. That's the deadline it has to be with UCAS. So if your school is giving you an earlier deadline, please abide by it, because they have to do lots of checking and reference writing and things after you have submitted it. And so please don't think, oh, Cambridge said that's not true. Listen to your school, they're very wise. There'll then be some additional forms. We ask for a little bit of extra information about some things. And then we have an interview. And as Anthony has said, he's going to talk through some interview questions for that. Those interviews take place in December. And I think the thing I want to say about them is, I love doing interviews. I really enjoy it, because what it is a chance to sit with someone who cares about your subject, or a couple of people who care about your subject, for 20, 25 minutes and talk about a thing that you all love. And there's not that many opportunities in life where we get to do it. And I know that interviews can seem really, really scary, but I think if you can get yourself into that mindset, that can really help you enjoy the experience. And then after the interviews, there's lots and lots of really difficult decision making to happen. The intercollegiate pool that I mentioned earlier happens, and then decisions come out in January. So that's the process that we go through. Now, I think that is all of my slides, so I'm going to stop sharing. Yes, I am. It's up here. And just check if there are any other questions at this point. Just drop them in the chat and drop them in the Q&A, and I'll be able to answer them. But I'm going to hand over now to Anthony. Thank you, Anthony.
Very much. Right, so bear with me here. I'm not great at technology, so I'm going to share that, and I'm going to share that, and by the power of the internet, Joe, can you see that slide? You can. Fantastic. So I'm now going to do for my next trick, and it didn't work, did it? Let me try. There we go. So hopefully we've got some kind of full screen slide now. So it's very exciting stuff. So I mentioned, my name's Anthony Ashton, and I'm one of two directors of studies at Homerton in mathematics. And as Joe said, we're there to kind of guide you through your academic path. So if you've got maths you want to speak to us about, we're the people who you'd go to. We'll also see you for lots of teaching and supervisions, but I'm going to come back to that in a second. So let's get started. If I go to, where is it? Page down, hopefully. Is that page down? That's page down.
It's not changing yet.
No, I've got it. Fine. I'll abandon
Now it's
page up,
changed.
page down. Let's do arrows. Okay, so first of all, there are three sections to this. So the first bit is mathematics at Homerton. So as Joe's already mentioned, all the students go to exactly the same lectures. You treat the college as a bit like a mini campus, and lots of the individual supervisions will take place on the campus. Again, I'll come back to those. But the exams are set centrally by the faculty, and you'll all be going to the same lectures that take place in the city and in the faculty in your third and fourth years. So there's Homerton. Beautiful, beautiful place to work, especially in the summer when the sun is out. Um, Facts about Homerton admissions. So we admit about 10 undergraduates every year. So that's the size of the cohort you'd be amongst. So standard offer is A star, A star, A, and we want the A stars to be in maths and further maths. And we also ask for 1-1 in step 2 and 3. Now, over the years, it's not been the case that 1-1 was necessary to get in. We have some people who have slightly different scores. Sometimes people have got in with, for example, an S and a 2. So that's not completely concrete, but that's what we'll be asking for in a standard offer. So the vast majority of the people who apply to the college, we interview. Now, there is a maths with physics option. So if you're not quite sure if you want to do mathematics or perhaps go into physics, what you're able to do is the maths with physics option, and you do then a little bit of physics and quite a lot of mathematics in the first year. And if you decide after that first year you want to go over to the dark side and join the physicists, then we allow you to do that. But I'd say in about 95% of cases, people stay with the mathematicians. And so there's a saying actually. So that the saying is, modern theoretical physics is locally isomorphic to pure mathematics. It's kind of a maths joke. Locally isomorphic means if you zoom in on it, it looks very similar. So you can do an entire maths degree if you want and end up being a theoretical physicist. More of that in a bit. So the majority of first and second year supervisions are conducted in college. So what on earth is a supervision? Fantastic question. So as I mentioned, you're all going to these central lectures. Now, the lecturers, perhaps after you've got through 6 or so lectures, they'll give you some problem sets. And the idea of those problem sets is they're problems based on the material of the preceding 6 lectures. And to learn mathematics, you must do mathematics. So you work on those problem sets to help you understand the lecture material. Now, it being Cambridge, those problem sets are tricky. So it's probably not going to be the case that you're going to get all of the questions or even the majority of them done. So that's where the supervision jumps in. That's where our supervisors, our academics, can help you with some of the problems that you might have struggled with. We might explain some of the concepts from lectures that you might have found a bit tricky. And it's all about adding to your understanding of the material you've seen. And it's kind of very much a partner in crime when it comes to lectures plus supervisions. They both help each other. So it's a wonderful part of the education system here at Cambridge, and it's great that you have so many supervisions in college because it means you don't have to wander off into some other part of town to go to some other college to be supervised there. We've got a great team of mathematicians at Homerton, and yes, so for the majority of those supervisions in the first and second year, you'll be at Homerton. What's this other bit? Pre-sessional courses. So we realised quite a few years ago that when people come up to Homerton or Cambridge in general, you've come from so many different backgrounds. So sometimes we have people, often if they've come from Eastern Europe, they're really, really good at things like geometry and combinatorics, but they're not so good at things like calculus and differential equations. Of course, I'm generalising. Whereas if you've gone to high school, let's say in the UK, you might have done lots of calculus, you might have seen umpteen differential equations, but you don't know what the pigeonhole principle is. Absolutely fine. The whole point of this pre-sessional course is we get to just top up your mathematics knowledge so you're all kind of a similar level. And more importantly than the maths, although I should have said that, more importantly than the maths is you get to build some camaraderie with the other members of your cohort. So mathematics, believe it or not, is very much a social subject. Lots of mathematics gets done when you sit around with friends and discuss problems. So we kind of give you a head start there. We want you to form close bonds with the rest of your cohort because they'll be the people you'll be talking to about most of the mathematics you do. Okay, so what else did I want to say? What you learn. So obviously you're going to learn some mathematics, but what kind of mathematics? Well, the mathematics degree at the University of Cambridge is about as broad as it gets anywhere. So for example, in our third year, at the current count, there are 34 different courses you can do in the third year alone. So you can come up to Cambridge and be doing a maths degree, and you can come out the other end a kind of mathematical economic person. You could come out the other end and be a theoretical physicist. You could be a fluid dynamicist. All manner of things, all going through the same degree, but perhaps making different choices along the way. So here is a list of stuff that you learn. This list is not exhaustive. I just got bored of typing them in. So functional analysis, Riemann surfaces, algebraic topology, the list goes on. And you can see from some of the words you can track on that slide, there is a massive range of things. So things like K-theory, commutative algebras, that's extremely abstract, pure mathematics. Whereas you can also see things like statistical methods, stochastic financial models. Perhaps you're thinking of going off into the city. Those sound like the kind of things that would be helpful. What else have you got there? I'm sure we've got something like integrable systems is very applied. You've got something like aeronautics, cosmology. So that's going towards the physics direction. This gives you an idea of the breadth that's on offer in the degree. So it's a fantastic opportunity, and it's a kind of wonderful world of mathematics out there, and you get to try all sorts of it. So let's have a look at a couple of the things you enjoyed. So I've extracted a couple of highlights from the mathematical tripos, and I thought you might like to hear about them. So the first one's Buffon's needle. So history tells us that one day this person, Buffon, this may or may not be a true story. Buffon was in a prison for whatever reason, and the guard said, let's say it's 200 years ago, the guard said, right, well, if you can give me the number pi, we're all familiar with number pi, 3.141, etc. If you can give me that correct to 50 decimal places, I'll let you out. Buffon, he didn't have much else to do, thought, right, well, I'll accept the challenge. So the guard was kind, and the guard said, look, I'm willing to give you some lined paper and a needle. So let me set up what Buffon was given in his cell. He had a huge page of paper, and it had all these lines, these horizontal lines, and they were separated by, let's say, 1 inch. He also had a needle, and the needle happened to be 1 inch long. And Buffon, after much thought, realised that if he just randomly dropped the needle on this lined piece of paper, he realised that the probability of that needle crossing a horizontal line was exactly 2 over pi. So that statement proving that the probability that the needle crosses one of those lines is 2 over pi, we actually do that computation in a first year course called 1A probability. So after studying the first year, you'd be able to prove in fact, why the probability of a needle crossing a line, if you just drop it randomly over that lined piece of paper, it would be exactly 2 over pi, so about 2/3. So when you think intuitively about probability, what does this 2 over pi represent? Well, it's a bit like when you say the probability of tossing a fair coin and getting a half. Well, where does the half come from? Intuitively, it's because, well, if you tossed it 100 times, you expect to get about 50 times heads and about 50 tails. So using that same kind of idea, do you see that the probability that the needle crosses the line, whilst we know it's exactly 2 over pi, we expect if we did loads of experiments, that would coincide with the number of times we got a needle to cross the line divided by the number of times we actually dropped the needle. So you can probably do this in your heads. You can probably rearrange that equation to see that pi is approximately twice times total number of drops divided by total number of times the needle crossed the line. And this was Buffon's fantastic idea. Again, may or may not be a true story. So he thought, right, let's start dropping needles and see what happens. And in fact, I recreated this experiment at the weekend. I had a lot of time on my hands. And you can see by the time, well, first of all, I dropped 7 needles. 4 of them crossed the horizontal lines. And if we use our formula from before, you see that gives me an approximation of pi is 3.5. So it's in the right ballpark, but it's not great. So after much trying, how was that one? So after 1,111,100 drops, 707,255 crossed the line. So I put those numbers into my formula, and you see the number I got? 3.142. Great. So we're getting closer and closer to that magic number. Unfortunately, and we can prove this again, but using some more advanced mathematics, if I want to keep doing this and hope to get 50 decimal places of pi, unfortunately, Buffon would be long dead before he got to about the 13th decimal place. So not a great way to get out of prison, but now you know. And of course, I wasn't really dropping 1,111,100 needles on a piece of paper. You can actually go and do this yourself. If perhaps when you go back in the recording and can pause it, you can have a look at that website, and it allows you to perform this experiment. So there you go, Buffon's needle. What else do we learn? Fermat's principle. So you might have heard of Fermat. So Fermat was actually a lawyer, but he also dabbled in mathematics. And Fermat's principle is actually something from physics, and it says the following. It says, if you have light that's going to travel from over here, point A, to over here, point B, it's not necessarily going to travel in a straight line. What the light will do is travel along a path that minimizes its kind of time of flight, which is incredible. We've tested this experimentally. This was Fermat's conjecture, if you like, and we've tested it experimentally, and it works. And you could start asking all kinds of metaphysical questions, because how do I know if the light is to go from here to here, and it's going to travel a path that's going to get it over to here as fast as possible? Well, how did it know which path to go down? Anyway, it's experimentally verified. This is Fermat's principle. And you might think, well, what good is it? Well, this actually tells you why we get mirages. So let me go on to the next page and show you what I mean. So you've probably seen this idea of someone stuck in the desert, and they're so thirsty it's unbelievable, and they think out in the distance they can see a lake. And the reason they think they can see a lake is because they see a tree, they see some haziness beneath the tree, and then they see what looks like a reflection of the tree. But in fact, this is just Fermat's principle at work. You see, when the person at point A looks forward, he sees the tree at B. However, he's also going to get some light coming down because it's warm air nearest the surface of the desert, and light travels quicker through warm air. So some of the light has gone down to the desert floor and then up towards the chap at point A's position. And because of that flight of the light, it looks like the light is coming from the ground. And of course, the person at point A, they try to make sense of this, and their brain kind of reconstructs what they're seeing, and it makes them think they're seeing a reflection of a tree. It makes them think there must be a pool of water there that reflection is coming from. In fact, there is no pool of water, and as we've seen in many films, when the person makes it over to the tree, they realise that it was a mirage, that it wasn't there at all. Well, you get mirages because of Fermat's principle. Something that you might have seen if you spent any amount of time on the floor of a playground, perhaps when you're a bit younger. On a really hot day, if you put your head down on the tarmac, you see a kind of shimmering. Well, again, that's Fermat's principle. That's because the air is very warm on the surface of the playground, on the surface of the tarmac, and the light coming down there bounces all over the place. So that's where you get your shimmering from. Again, this is something that you learn about in the second year of the mathematical tripos in a course called 1B Variational Principles. Okay, what else? The Banach-Tarski theorem. This one I don't think you'll believe. This is so some people call this a paradox. It's not a paradox. This is very, very real. So the Banach-Tarski theorem says that if you give me a ball of radius 1, so like a solid ball of radius 1, I can break it up into 7 bits, and using those 7 bits, I can reconstruct 2 balls of exactly radius 1. Now, I know what you're all thinking. You're thinking, well, that's impossible. You can't do that. So, for example, if the first ball weighed 1 kilo, and then if I had 2 identical balls afterwards, then I'd have 2 kilos. And you can't make 2 kilos out of 1 kilo. That seems ridiculous. It violates conservation of mass. Well, that's because you're all thinking like a physicist. You see, the mathematician, you haven't thought hard enough about what kind of shapes I can break the ball into. You see, what if I were to break the ball into shapes that were so complicated, we couldn't even make sense of their volume? It wouldn't even make sense to talk about the volume of one of these 7 bits. They were that complicated a shape. Well, it turns out if you do some geometric measure theory, that's probably beyond the tripos. Actually, no, maybe if you did part 3, you might learn about that. But you can prove that this theorem is absolutely correct. And how bizarre. I remember when I first heard about this and I really didn't believe it. I had to read and understand the proof before I thought this was a real thing. So there you go, Banach-Tarski paradox. Right, duck versus speedboat. You'll have heard about this, I'm sure. It's the battle that's been going on over centuries, if not millennia. When you've got boats and you've got ducks in a lake, they're always trying to compete for which one has the larger wake. So as you know, when ducks and when boats go through the lake, they produce a wake behind them. And the question is, which wake is largest? Does the duck produce a wider wake, or does the speedboat and produce a wider wake. A little bit of artistic license here. I'm a mathematician, of course, not an illustrator. So this
I
is a
think it's
question
a
we
very
always.
lovely duck, Anthony. I like a duck.
I spent at least 45 minutes on that, so I appreciate that. Thank you, Joe. So this question that you can answer with something called linear wave theory, which you learn about in part 2 in a course called Waves. So if you want to be a fluid dynamicist, you'll be able to answer this question in a few years' time. So ordinarily I do something like a poll, but let's just, you have in your mind's eye which one you think is bigger, either the speedboat or the duck. Now, I'm not a mind reader, but if I give you 3, 2, 1, everyone's wrong. Everyone. Because I gave you a false dichotomy. It's not that alpha is bigger than beta or beta is bigger than alpha. You can actually prove using this kind of linear water wave theory that alpha and beta will be exactly the same. So when you next find yourself out on a calm lake, you can have a look at the speeding speedboat and the calmly swimming duck. You don't need experimental evidence, I'll believe you. You'll find that the wakes are the same. Incredible. So there we go. So that what we've talked about there is some of the stuff that you learn in a mathematics degree, and I'm kind of hoping that you might be surprised by some of it. So sometimes when you're doing high school mathematics, it's a bit boring. You can only solve so many simultaneous equations or integrate so many polynomials. Some of the problems we work on the degree are really interesting, and that's what motivates us to come up with more and more advanced mathematics so we can solve more and more interesting problems. So that's the degree, but what happens before the degree? Of course, there's the application process and the interview process. So now what I'm going to do now is go through a problem that I used, I'd say up until about 2016. I've been sharing it since then, so I'm afraid I'm not going to use this this problem in our interviews if you do come along, but it is indicative of the kind of thing we look for. So before I go into the actual problem, there's just some broad points. What do I want to see? These are obvious, but sometimes it's worth stating the obvious. So genuine interest in the subject. Maths is hard. You're going to have to work hard. It's really, really difficult to put loads of effort into something you're not enjoying. So I have to see that you're enthusiastic. Obviously, I want to see that you've got a good grasp of the A-level material or equivalent that you've been studying. One of the big things, logical thinking and the ability to produce sound arguments. One of the things we like in mathematics is rigor. We like arguments to be clear, and we like the idea of clarity of thought. So that's one of the things that you can actually practice. So when you think you've solved a puzzle or a problem at home, try to explain your solution to a third party. That's what mathematics is all about. You trying to solve a problem and then convince a third party you really have solved it. So the communication part, that clarity of thought is incredibly important, and that's something you can work on. What's this next bit? Take on new ideas and use them in unfamiliar settings. That's what happens in a lecture, right? So we lecture, we give you a new idea, we might give you an example, and then we move on to something new. So I want to see that you're able to absorb new ideas and then perhaps use them in unfamiliar territory. So what actually happens? What are the practicalities here? So Joe mentioned this. If you enjoy your subject, the interview is actually good fun. You're going to talk to someone like me. I really like mathematics. I'm going to talk about fun puzzles. And the second you get stuck, we'll let you think about the problem for a while. But if you need a hint, you effectively need to tag us in. That's fine. I'll jump in and I'll give you a little bit of guidance, and then I hand the reins back over to you. So it's a fun, enjoyable experience, and it's not something you should get hung up about. I know it's easy to say that, but no, it really can be an enjoyable experience. Things that would make my life easier. So first of all, please don't stare into outer space for long periods. What I mean by that is you might be thinking brilliant thoughts. So because you guys are all so clever, what often happens is I ask a question and the candidate will go, oh, right, okay, to answer that, I could use calculus. But then in their head, they go, oh, no, can't use calculus because it's a problem on the integers. So I don't really have this continuum. And they just, but all that time, they're great things. They've spotted that, oh, maybe I could use calculus. No, I can't use calculus because it wouldn't work in this setting. You get credit for saying both those things. But if you're staring into outer space, having that inner monologue, I can't give you any credit. So please tell us what you're thinking. That's super, super important. If you're not familiar with something that we ask, if we use a mathematical word that you're not familiar with, it's absolutely fine to just tell us, And if it's something you haven't covered in school, we'll move on to another problem. We've effectively got an infinite stack of problems. That's absolutely fine. And if it's just a case that you use a different word for an idea that's actually familiar to you, well, we'll give you the alternative word and we can crack on. So yeah, it's all about being open. And if you get stuck, tell us. And yeah, tell us what you're thinking. Very, very big deal. Okay, so here's the example interview question I alluded to before. So this is where things are going to get tricky because I have to do this. And if I do this, bear with me 2 seconds. Dot square, perfect. Okay, so Joe, can you see that the square and the?
No, not yet.
Let me just do this.
Oh, much better.
Ah,
It's not
brilliant.
there yet.
Okay.
Not,
There we go.
oh, yes, now I can. There's a square.
So okay, so here's what the interview used to go. Someone would come into my office, say, "Hey, how are you? How's the journey? Have you come far, etc. Isn't it a lovely day?" And then we'd say, "Right, let's talk about maths." And the way I do that is I take this piece of paper, I would have printed it out, and I probably would have put it on the desk in front of me, and I would say, "Do you want to have a read of that?" And then we'll chat about the problem. So let's kind of collectively read this thing and see where we're going. So as you can see, we've got a square. It's a 2 by 2 square. And my claim is a very grand claim. It's if there are 5 dots inside this 2 by 2 square, I claim that I can find 2 of them that are within a distance of root 2 of one another. So my usual line of attack, I'd just be quiet now, and I'd let the candidate think a little bit about this problem. Again, we don't mind silence for a while, but ideally we'd like you to be telling us what you're thinking. So I usually break the silence, because it's a tricky problem. I break the silence, I usually say, well, look, we've only just met. You don't know I'm a very trustworthy individual yet, so maybe I'm lying. Maybe it's the case that my claim is false. So if the claim was false, let's say you were convinced that it was false, how might you provide a counterexample? And the candidate would think for a bit, and they thought, right, well, counterexample, well, if I've made a claim that no matter how you distribute the 5 dots, I can always find a pair of dots within root 2 of each other, a counterexample would be some array of 5 dots that are such that no 2 dots are within root 2 of each other. And I say, right, okay, well, why don't you have a guess? If you wanted to provide a counterexample, what's your kind of intuitive guess for what would work? And usually some people go a dot up here. I hope you can see this. A dot up here, a dot up here, a dot up here, and a dot right in the middle. This is 9 times out of 10 the guess that people come up with, because they say, look, really what I want to do is spread the dots out as much as possible so I don't find any pair within root 2 of each other. And this is probably, intuitively the best I could do. So then I think I looked at the candidate and say, right, well, for this array of dots, is it true that no 2 dots are within root 2 of one another? Perhaps what's the distance between this central dot and this dot here? So I asked the candidate that, and the candidate, they'll know about Pythagoras's theorem. I know you'll have seen that, and you'll know that this is going to be a triangle. That side would be 1, that side would be length 1, and that means that this length here, by the power of mathematics, is going to be root 2. So it looks like this is not a counterexample to my claim. It looks like if this is your best guess, then my claim is still true. So I say, right, let's go back to the drawing board. Can we maybe come up with a proof that my claim is true? Because it's looking like our best case failed. So again, I let the candidate think for a while. This next step is very difficult, and I think maybe over the past, I used this for about 7 years, and I'd say maybe 2 candidates got this in those 7 years. So this bit was really tricky, but I would be expecting to give a hint. The hint I would expect to do is say, let's divide the square. Apologies for let's divide the square into 4 equal 1 by 1 squares. And I'd say to the candidate now, does this help? Does this kind of artificial splitting of the larger square into 4 smaller squares help? And at this point, I'd let the candidate think, and often, maybe after a minute or so's thought and some kind of playing around with ideas, they might come up with the following idea. Here's the idea that I want them to think about. They say, right, well, I've got to distribute 5 dots in this big square, But this big square is the same as 4 small squares. So if I've got 4 small squares and I've got to distribute 5 dots amongst them, what can you guarantee about one of these smaller squares? Well, what you can guarantee is that it's going to have 2 or more dots in it. So I must have one of these smaller squares that's going to have 2 or more dots in it. What we're actually doing here is invoking something called the pigeonhole principle. Doesn't matter if you haven't heard about that. But here's the idea. You've got 4 things and you're trying to distribute 5 dots amongst them. That means there must be at least one of the things with 2 or more dots in. Once they've got that, they're on for a home run. Because you can now say, well, look, if I've got 2 dots in, say, this same 1 by 1 square, what's the most you could separate 2 dots in there? Well, the most you could separate 2 dots if they're in the same square would be to put them, let's say, at opposite vertices, opposite corners of the square. So if that were the case, what's that distance? Well, we already know that distance is going to be root 2. So to recap, and this would be the important thing when I say I look for clarity of thought, because I've given the candidate a new idea there. What I'd ask the candidate to do is, right, now can you give me a concise and clear argument as to why my claim is true? And what I want to hear is something along the lines of, well, I can artificially cut my 2 by 2 square into 4 1 by 1 squares. Because we're distributing 5 dots and I only have 4 1 by 1 squares, there must exist a 1 by 1 square with 2 or more dots in. Now, what's the maximum separation of 2 dots inside a 1 by 1 square? It's root 2, and that means the claim is true. That is, I can always find 2 dots that are going to be within root 2 of each other. Now, as a kind of bonus question, I asked them the following. I'd say, right, we've found that my claim is true with this magic number root 2. The bonus question is the claim true if I change root 2 to a smaller number? You know, because if I'd said I can always find 2 dots that are within 10 of each other, that's not very impressive. You know, my claim is more and more impressive the lower that number goes down. So the question is, can you make root 2 even smaller and this still be a true statement? Well, this is a tricky one, but often after a bit of thought and perhaps a hint from myself, they realise they've already got a counterexample. Let's say you put a smaller number here, a number that's smaller than root 2. Well, consider the following arrangement. 1 dot there, 1 dot there, 1 dot there, 1 dot there, and 1 in the middle. What's the closest any 2 dots are here? The closest any 2 pairs of dots is root 2. So if you'd given me a number that was smaller than root 2, here, this would provide us with our counter example. So there we go. That's an interview question. If you notice, I gave you a trick. Yeah. I effectively gave you that pigeonhole principle. The underlying trick here was we took the big shape, we cut it into 4 equal shapes, and we said we've got 5 dots, 4 little shapes. There's got to be 2 dots, at least 2 dots inside one of the little shapes. That's the new idea I've given. And if you remember in one of my slides, I say I look for the ability to absorb new ideas and use them in unfamiliar settings. So here is that unfamiliar setting. I say, right, finish the squares, we're on to triangles. And we want to make a similar claim. This is a 2 by 2 by 2 equilateral triangle. And my claim is, if I put 5 dots inside that equilateral triangle, I'll always be able to find 2 of them within a distance of x apart. My question is, what's the smallest x so that the claim remains true? So remember, I've given the candidate that new idea. The new idea that helped us solve the previous problem was splitting the shape into 4 similar shapes, 4 shapes that were all equal. So I'm hoping the candidate's going to try and do the same game here. Now, if you're old like me and played video games in the 80s and 90s, you're at a distinct advantage because you'll have no doubt played on a game called Zelda. And if you have, you'll have heard of something called the Triforce. So the shape that I would be hoping the student might draw to split this large triangle up would be something like this. So you see, by drawing that in, I've now got 4 triangles. They're all the same. They're all 1 by 1 by 1 equilateral triangles. And the student, I would hope, might argue along the same lines as we did before. If we are to distribute 5 dots inside that large triangle, that means ultimately I'm distributing 5 dots amongst those 4 triangles. Because there's 4 triangles, 5 dots, that means there's going to be a triangle with 2 dots or more in it. And because they're all the same triangles, it might as well be that triangle. Okay, so let's say that's the triangle that has 2 or more dots in. What's the most we can separate 2 dots inside one of those triangles? Well, it's precisely when the dots are at the vertices or the corners of the triangle. It'd be precisely when you put them, let's say, there and there. In that case, they'd be a distance 1 apart. So because of this argument, again, I would ask the student or the candidate to now concisely present your argument, and they do similar to what they did last time. And they'd say, right, this claim is true if x is equal to 1, because of that argument that we gave just now. However, what we haven't done, we haven't shown that 1 is the best possible number. You know, this argument here shows I can always find 2 dots that are within 1 of each other, but I don't know, there isn't some magic number and some smarter argument that would give me an even better bound. So I could make that x, which is currently 1, even smaller. Well, just like in that previous question, if I want to show that I can't make x any smaller, I could just give you a clever distribution of 5 dots so that no 2 dots are any closer than 1 apart. So I wonder, while I'm getting rid of this stuff, can you think of a distribution of 5 dots here for which no 2 dots are any less than 1 apart? So I'm thinking vertex, something there, let's say something here, and let's say something here. What's the smallest distance between any 2 of these dots? Well, because I've drawn them on these vertices, we can see that the smallest distance between any 2 dots is precisely just 1. So if you tried to lower that x, if you made this claim with some x smaller than 1, this would prove as a counterexample. So in fact, x equals 1 is indeed the best number that you can do. Now, that's about where I want to finish, but there's some reassurances. We went through that at light speed. I talked an awful lot, and it's a bit of an artificial way in which to present the way in which the problems are done. It's all about conversation. There'd be backs and forths. I wouldn't be speaking so quickly, and you'd have more time to think. So don't think that I'd be expecting you to go through these things just as fast. It's just because we've only got finite time on this planet, I have to move fairly quickly in the talk. Yeah, I'm pretty much done there. So if I stop sharing my screen, and I guess we can go over. Is it Q&A time now, Joe? Super.
And this is when Kira comes into her own as well.
Magic.
Can you see the Q&A, Anthony?
I'm just pulling up now. Bear with me.
I've answered some as we've kind of gone through.
Do they start from the top? Is that the right way to do it? So
yeah.
Okay, so one I have here. So do you need further maths to apply to Homerton College? We do require further maths, and that's because the course itself assumes knowledge from the further maths syllabus. So that is a requirement, absolutely. Does Cambridge give more offers than places due to? Yes, absolutely. So this happens actually throughout the universities. So we don't give out precisely the number of offers as we have places. It's always the case that some people don't quite make the grades that we've asked for, but that's completely standard practice. So yes, that is true. Can we ask how many candidates apply to Homerton College each year? You certainly can. So it fluctuates. There's a bit of variance, but I'd say on average we get between 50 and 60. And I'd say of those, we give about 20 offers, there or thereabouts. Okay, so they're not exact numbers, they drift from year to year, but from the stats in my head, that's about it.
And I think it's maybe worth saying that those offers come from direct offers from us, but also from the pool. That's kind of standardization that happens.
Absolutely, yes. So that was so somebody asked before, didn't they, whether or not it matters which college goes to which. So when I say 20 offers, that's in total. That's from the people that we've interviewed directly and the people that we've taken from the pool. The pool is a great setup because it combats precisely the issue that the anonymous person brought up. We get because of the variance in applications from college to college, it will always be the case that some years one college will be oversubscribed, one undersubscribed, and vice versa. That means that where the oversubscriptions come, they go into the pool. And then the colleges that have been undersubscribed, we can take from the pool. So the system works really well to combat that precise thing. So yeah, thank you very much for that, Joe. I've completely forgotten. What's the next one? If you did maths with physics option when you first apply, so you do put on there is a with physics option on UCAS, but from the point of view of Cambridge, once you've come to the college, you've actually got complete freedom just to carry on with straight maths or maths with physics. In fact, what happens sometimes is people have put down maths with physics, and then they arrive in October and they say, actually, I'd probably prefer to just do straight maths. And that's absolutely fine. That only changes when we enter you into exams. You've also asked something, take maths with physics option. Do you compromise on the lab works that the physicists would normally do? So you do 3/4 maths. No, you don't. 7/8 maths and 1/8 physics. And the physics, if I recall, it is not lab-based work. And it's actually the lab-based work that puts people off going to straight physics in their second year, because that takes a lot of time from the physicists. And whilst people might like to solve the physics problems, as in, a ball rolling down a hill, how fast will it be going, etc., they like to do those things, but they don't necessarily like to do the lab work that the physicists have to do in terms of kind of experimentation and phenomenology and things.
Sorry,
that's all right. So someone says, is it good if you've got IMO experience, International Mathematical Olympiad experience? Absolutely. That's kind of rock star mathematics, right? Having said that, I don't expect you to have had any IMO experience. I went to Cambridge a billion years ago, and the first time I heard of the IMO was when I got here, and I did just fine. So it's absolutely not necessary, but it's a great thing to put on your CV if you've done that kind of thing. So yeah, very good question. You don't have to really do any supercurriculars. I mean, one of the great things about the University of Cambridge, once you've matriculated, you can go to any lecture that you like, but usually you'll be full up with doing maths. So there's not that much time to go and do. There is a counterexample, a famous one called Sir Michael Atiyah, and he did the architecture tripos at the same time as doing the maths tripos. But Sir Michael Atiyah won a Fields Medal. So he's not your normal mathematician. But yes, you can go along and see stuff. But to be honest, what you'll find, and this I remember thinking similar things when I came up to Cambridge. I remember thinking, well, I probably just want to learn practical things because then I'm going to go into the city and earn lots of money. How wrong I was. What you find is the maths is actually really good fun. And there's it's a self-fulfilling prophecy. You start learning more maths and then you start wanting to do more maths. That's usually what happens. And because I mentioned before, the example sheets, they're quite tricky. They're not like doing exercises in school. They're much more like doing problems and puzzles. So you get a great sense of academic achievement when you manage to get through them. It's not like the dull stuff, greatest respect for A-levels and things, but it's more fun maths than you get to do in school. Right, questions coming thick and fast. What does a successful maths applicant personal statement look like? Fantastic question. Do you know what? All I want to see in a personal statement is evidence of enthusiasm. That's the really big thing. Look, maths is hard. And if you're not really enjoying maths when you come along to Cambridge, it's going to be really, really hard. Sometimes it gets so hard that people have to change tripos because they go, you know what, I'm not actually that into maths, which is perfectly fine, but it's not an optimum route for the candidate. So for me, central importance, I want to know that you're enjoying what you're doing and perhaps evidence that you've looked a little bit along beyond your curriculum to see what you're looking forward to doing, maybe in the first year. I'm not asking you to kind of recite stuff in the annals of mathematics, but to know a bit of stuff that you might see in your first few weeks of few weeks of university, so that's good. But enthusiasm's the big thing. So I'm applying for maths at Cambridge. However, everything university I'm applying for, joint maths and computing. Oh, so my personal statement's got a lot more computer science in it. Realistic, no, no. Again, so I am sure in your so the question effectively is at other courses I'm doing maths with computer science, but my Cambridge application will be for straight maths. Of course, the statement will be tailored to computer science and maths. Will that affect? So no, because I'm sure in that statement you will have also expressed enthusiasm for both mathematics and computer science. Of course, I'd be more interested in enthusiasm for the maths, but on top of that, for the Cambridge application, there is actually a little box where you can add extra stuff. If you think there's something that's particularly relevant to the Cambridge application, you can fill in a little extra stuff in there. So if you wanted to kind of bulk up and say, look, I'm actually really enthusiastic about maths, you might fill in a bit more there. But certainly that wouldn't harm your application, no. Do you require face-to-face interviews? So what a wonderful question. I'm glad that came up. So this year, but everything got turned upside down after COVID. So what we're doing this year, and I hope to kind of return to some sense of normality, we're going to give home students the opportunity to have an interview in person if they'd like. And if they would prefer to have it online, that's absolutely okay. And for international students, to save you coming all the way to Cambridge, we're going to say that we're going to do the interview online. So I don't know if that's actually gone live on the website yet. I don't know if it's up there, but that's going to be the policy. So basically, if you're a home student, you get to choose, and if you're an overseas student, you don't have to do that big long journey. So there we go. So hopefully that answers that one.
We've done that. There you are.
Are the questions you get in an interview random, or are they based on your personal statement? Well, they have to be normalised. So I'll be asking all candidates, at least candidates from the same day, the same questions, because we want to be able to see. So sometimes you don't know how tricky a question is until you've asked it to a few people. So once I've asked the same question to, let's say, 10 people, I've got an idea then of how each person performed. So no, they're not tailored to the individual, but I'd say I tend to change the problems every day. That gives me a big enough data set so I can kind of get an idea of how people performed on each problem. Having said that, if you say, oh, I absolutely love number theory, I might say, oh, fine, what's your favourite bit of number theory? But we'd probably move on from that quite quickly. Does it matter which further math modules you've taken, though? No, it doesn't. It doesn't. So that was it. How important is a good... So the interview is important because, do you remember I mentioned before that one of the things in the interview I'm looking for is I want to see how good you are with taking on new ideas and then using those new ideas in an unfamiliar setting. And the reason I want to see that is because that's almost exactly what happens in the lectures. Every day, every maths lecture you go, you'll have new ideas come at you left, right, and centre. And you have to be able to absorb them, not possibly in real time. Sometimes you have to go back to your room and work and think a bit, but it's all about absorbing new ideas. So the interview is an important aspect of the application, yes. If we come across a familiar problem in the interview, should we bring it up? Yes, that would be the very fair thing to do. So if you've seen, I mean, for two reasons. One, it's the honest thing to do. But two, if we fly through a problem really quick, because you've already seen it, do you know what we're going to do? We're just going to ask you another problem. You're going to be in my office for 25 minutes, there or thereabouts. So if it turns out that we just fly through one, there'll just be an extra one. And as I said, I've effectively got an infinite pile of questions, so we will never run out. But yeah, very, very good question. Very good question. What kind of jobs would maths at Cambridge open up? Well, the world is your oyster. I mentioned before, let me think, so I know examples. One of my friends graduated from Cambridge. He really enjoyed analytic number theory. You might learn about that in things like part 3. Do you know what he does now? He is European head of logistics for Tesco. And you'd think, why on earth would Tesco want someone with a lot of knowledge of analytic number theory? Very good question. They don't necessarily. What they wanted is someone with an analytical mind, because this would be back in 2006. Online delivery started to get quite big. You know, when you can get your shopping delivered to the door? Well, you imagine your Tesco, you've got delivery vans going all over the place. So you want to know within a tenth of a second how you can draw up the most efficient routes for each van so you can save Tesco on petrol. So that's how he entered into Tesco, and now he's high flying. On the other end of the spectrum, I know someone who's gone to work for BP because they want to better figure out how oil goes down pipes, and that's all done using fluid mechanics, viscous flow, and things. People who've become theoretical physicists. They were pure mathematicians. They did a PhD in pure maths, but it turned out that pure maths was important in some area of string theory, probably. And now they're closer to theoretical physicists. People who go into the city and do things with economics, kind of stochastic financial models. People who go into software engineering. Big data. That's the thing that you put down on a research proposal now if you want to get grant money. Big data and AI. So the mathematics of AI is the statistics of big data. So if you want to be an AI consultant, and it looks like that's the way the world's going, then you should do a course in the third year called Mathematics of Machine Learning. And from that, you might start developing some very clever ideas that might help us when the AI overlords take over. Right.
But just Anthony, just because we've got Kira here as well, who might have thoughts about going on and aftermath. I wondered if you wanted to share anything.
Yeah, so I'm graduating this week actually. I'm going into the civil service next year. I'll be working as a project manager in the civil service. It's a grad scheme, so I'll be learning on the job a lot. And again, yeah, that's something that doesn't seem to directly correlate to maths, but a lot of the skills that I picked up doing the degree will be very, very useful. So yeah, that's what I'm doing next year. I think there's quite a lot of students that go on and do masters and PhDs as well, but it's certainly not the only route. There's a big mix. Yeah, big mix of things.
Brilliant, thank you. Done there.
I'm predicting 4 A stars in my A levels. However, I only have 3 grade 9s and this and this. Should still apply? Yes, but my advice is yes, still apply. So for me, I'm very much aware of the fact that the person you are academically at 15, 16 is very different to the person you could be at 17, 18. I was a bit of a naughty boy, and my GCSEs aren't fantastic, and my A levels are absolutely fine. So yes, I would say that's not a problem. If all your teachers think you're getting A stars in your A levels, then that's a very good chance that you'll be invited to interview. Do you have any advice on getting good step grades? Oh, fantastic questions. I'll give my tuppence, but then I might ask Kira because she did them more recently than me. Practice. The first time you see a step problem, you'll think this is impossible. This mountain cannot be climbed. And then you'll finish your first step problem, or maybe get 3/4 of the way through it. And you think, well, hold on, maybe I can do this. And then after a few weeks, maybe you've done 3 or 4 problems and you're starting to gain some momentum. You've noticed that the same tricks come up. The question looks different, but the trick, the idea is the same. And you start doing more and more past papers and you think, okay, this is going to be tricky, but it's not insurmountable. So for me, practice. But I will defer to the expert, Kira.
No, I'd agree with that. There's also, if it's still running, there is a STEP course that's offered to all state school students, I believe. I don't know if that's still running.
It might not be still running.
It might not be if not, but I found that very useful when I did it. But there's a lot of past papers online, like years and years and years worth. So yeah, definitely past papers very useful, and just knowing the syllabus sort of inside out. It's not got the biggest syllabus. It's basically all of A-level maths, but just what you know, make sure you know it very well, basically.
Yeah, if I put something into, if I put a PDF file into the chat, are they able to download it?
I have no idea, but let's try and see.
So
I'm putting links in to answer a lot of these questions, because then they can access things like that. So there is, I've just found the link for it. The step preparation support does seem to still be running.
Okay. Oh, it's under a different name then. Okay, so let me just
program. Yeah.
Yes, let me just pull this up because I wrote. So there's a great thing by a mathematician. He was called Stephen Seacloss, and he put together something called Advanced Problems in Mathematics. Let me just type that in.
I've put the link to that up already.
Okay.
So by all means do it again, because doing it more times is not bad. But I've put the link to the Homerton resources page, which has it on there.
Oh, perfect. Okay, good, good. So I'll see if I can find, or if not, I'll make it available on the website. I too have tried to emulate Stephen Seacloss, and I've got a booklet with lots of problems in, some hints, and some solutions. So I'll arrange for that to be put on the Homerton website, so you can also use that. But basically, the more resources, the better. The more attempts you can do, the better. The more familiar you are with the material, the better. And start early, even if it seems like it's a very difficult task. Start as early as you can, because of course, then you can get more done. Goodness me. Do you
Do-
review the... Sorry, Joe, do you want to do the...
No, do you review direct application and Winterpool at the same time? We review the direct applications, we interview. The Winterpool happens after that, but before any offers are made. So it's not exactly the same time, but within the same time period.
Question we've got in the interview, how much of it is doing maths versus how much is general discussion? It's about 95% talking maths. We're pretty straightforward with that.
Kira's very sure about that.
How much does your personal statement matter when applying to the mathematics, or is it better focus time elsewhere? Well, again, the personal statement matters in as much as you can convey to me that you've got lots of enthusiasm and you're someone that would, you know, enough enthusiasm so that even when the going gets tough in the degree, it would be enough to keep on pushing you through. That's the main thing I'm looking for.
Mm-hmm. Do you have a maths book that you recommend reading or enjoy the most?
Oh, good question. There was, yeah. So there is a great book by somebody called Tom Kerner, and it's called The Pleasure of Counting. That's good fun. It's not really it's not really a book that's going to train you up for step or anything like that. But it's just if you enjoy maths, it's good. And there's also one. It's much older, and it's called, oh goodness me. I will put it in the chat. I'll remember it in a second. It's called like The Art of Problem Solving, and it's by a Hungarian mathematician. I will come back to you.
Kira, any favourite maths books?
I'll be honest, I don't think I've read any maths books since sixth form because the degree is quite intense. I think Simon Singh has a few books. I think there was one to do with The Simpsons. I remember reading that. But generally just whatever you're interested in, doing more of that is always helpful. So if you're really interested in number theory or geometry, finding a book related to that. But yeah, generally I prefer to like find problems to do, like puzzles like that, rather than reading about them. Often the books also have that included. So yeah.
Yeah, brilliant. Thank you. I think that's a really key point though that Kira's made. Do the things that you enjoy. Don't, come along to this, and I'm sure Anthony's suggestions are really great. But if they're not the thing that speaks to you, we all like different parts of maths, and that's absolutely fine. Great, thank you. At interview, how many of those questions are covered in 20 to 25 minutes? It really, really varies, I would guess, is the answer, Anthony.
Yeah, absolutely. So some questions they're quite short and they're quite nice because when you first come in, I might give a question that wouldn't take so long, so we kind of boost your confidence a bit because I know people are nervous and we don't want you to be nervous. So the questions don't all take an equal amount of time.
And I think certainly from the interviews that I've done, sometimes it takes people longer to get through part of it, but that's not necessarily a problem. It's just how working through them together. So don't feel, oh, I must tick off 5 questions in this interview. That's really not the way it works.
No, absolutely. I mean, sometimes, depending on the question that I've designed, I might only expect to get through one. So please
or
don't...
even part of one.
Yeah, even part of one. So please don't think in the interview kind of like, oh, I've only got up to 1 or 2. That's not how it works at all. So don't worry. I have a particular interest in a specific area of maths, and I'm likely to write about that in my personal statement. Would this make it more likely that I guessed asked for an... So I'm not going to quiz you on it. So there was a trend about 15 years ago. A book came out by Roger Penrose, and it was called The Road to Reality. And he rather optimistically took you from Pythagoras' theorem to supergravity. Supergravity is beyond graduate level maths. Lots and lots of candidates say, "Oh, I read that book," and we often said to the candidates that mentioned that, we said, "Really?" Because I got stuck on chapter 12. So what I'm saying is, don't lie about what you've done. Don't over-egg it. We might ask you, but we're not going to quiz you on it. So we might say, "Oh, which bit do you enjoy of that particular area?" And you might tell us. But just putting down some fancy maths words, if you don't know what they are, it's probably not going to help your course, so it's not worth it. But by all means, if you're interested in a specific area, let us know. God, the questions keep coming. So which is absolutely fine. If you complete maths in the first year of A level, would it be included in your offer to do further maths? Oh no. So if you've already got the A star in maths, it would just be then the A star in further maths.
We don't make you do it again.
No.
Kira, I think the next one's for you. What would you say is the biggest pro and the biggest con of studying at Cambridge?
Yep. Probably got hundreds of answers for this, to be honest. Big pro is obviously it's Cambridge. There's like world leading academics here. You're surrounded by other people who genuinely enjoy the subject. I don't think many people can get through STEP if they don't genuinely enjoy the maths. So you're surrounded by like-minded people. There's so many opportunities at Cambridge as well, like societies as well, things outside of academics, sports, music, arts, things like that. And Cambridge itself is a lovely place. So that's the pros. Biggest con, probably as Anthony said, if you don't actually enjoy the subject, you're in for a rough time. Personally, I'd say the biggest con is the fact the terms are very intense. So it's 8 weeks and you need to be on top of things for those 8 weeks. It's very easy to get behind on things, as I've experienced myself a few times. So I'd say that's the biggest con, but at the same time, it means you get nice long holidays in between. So if you do need to catch up, you have time to do that. But yeah.
Brilliant. Thank you. Do you read the personal statement before interview? The personal statement is one of the things that we look at in deciding whether to invite people to interview. We do enjoy reading them. We like to hear about your enthusiasm for your subject. So please don't, and I know that sometimes it feels like, oh, people are never going to read this. We do read them, and they are used in that decision making. Done books and authors. Is it possible to continue directly into a master's and PhD program at Homerton?
So so the undergraduate degree is parts 1A, 1B, and part 2. That's the first 3 years, and if you want to stay on, we have a fourth year called paradoxically part 3. And if you do part 3, then absolutely you can go on and do a PhD after that, and you can do all of that while staying at Homerton. We'd love to keep hold of you. So yes.
And the part 3 is a master's, isn't it?
Yeah, absolutely, yes.
Yeah. Is it advised to do STEP a year early, and how will this affect the offer given out the following year?
Right. So I think you should start on STEP as soon as possible. But in my experience, if people kind of have a go at STEP in their first year and they don't do very well, often it can be a bit demoralizing. And I don't want any applicants to be demoralized. My view is focus on the preparation for STEP for the longest time you can, and then do the exams at the end of that. So of course, at the end of your second year, you'll have done more maths, you'll be more prepared for the exam. So that's my advice.
Thank you.
So the entrance exam. So again, we're in a slight state of flux at the moment because we're not going to do entrance problems for either the online or the in-person interviews. So the problems that you see at interview will all be presented during the interview. There won't be any kind of like pre-interview reading. We used to back in the day, but now because we've got the split between some people online and some people in person, it's very hard to administer the kind of pre-interview test. So we've dropped it, at least for now.
Oh, sorry, I forgot to press. There we are. What's the most appealing thing about Homerton College, in your opinion? Do we all get to answer this?
Go on, Kira, you should go first.
What is the best thing? I'd say all the green space. I think particularly at the moment with the heat, it's very nice. We've got a lovely orchard at the back. We're allowed to walk on the grass at Homerton, which isn't the case at all colleges.
Which is really important, isn't it?
Yeah. So you can have picnics on the grass if you want, things like that. But yeah, the gardens are also really well maintained, lovely flower beds, things like that. So yeah, the green space, I would say.
I'll go next. For me, the best thing about Homerton is all the people that I get to work with, and that's both colleagues but also the students. I really don't like this time of year because everyone leaves for 2 months and I have no students, and it makes me sad. But it's lovely that they'll come back next year and new people will join in next year. But that being able to work with all these wonderful people who really, really care about their subjects. Anthony?
So you've stolen my. So I was going to go for the people as well, but So I think on top of that, so the bonus. So we're certainly not on the outskirts of Cambridge, but we're kind of towards the railway, if you like, and that means we've got these huge college grounds, and we have the kind of spaces where you can, I don't know, play football on an afternoon and then walk 100 yards to your bedroom, or walk 100 yards and go and have lunch and something. When I was a student at the college I was at, our football ground was about 4.5 miles from the college. So the idea of going to play a kind of a match on a Sunday afternoon was a real pain because you were tired before you got there. So the proximity of the sporting facilities to the college is fantastic. It's a lovely place to work. I've been at several Cambridge colleges, and Homerton is without doubt my favourite because of the setting, the people, and the place. So there we go.
Yeah, it's nice to be able to sit here and say these sorts of things, isn't it? Like,
it's lovely.
It's nice to have the opportunity. Do you think work experience is necessary or very applicable when applying for maths? That was live, but with no voice. There was head shaking. What is the cutoff IB score in order for the personal statement to be looked at?
So on that, I'd say it's not a hard and fast rule. So I think we look at the application as a whole. So people have mentioned, if I'd done this at GCSE, or perhaps if I'm predicted such and such in this thing, we don't look at any one factor and that be the determining factor. We look at it as a whole and decide based on that. So don't worry if you think there's one part of your application that might be a little bit weak. Don't let that dissuade you from applying, because then when we look at the application as a whole, we might think, well, yeah, there's a little blemish there, but it doesn't matter. Just interview the person.
I have linked for a number of other questions like this as well, the information about the entry requirements. The maths page for entry requirements does just labels a few, but there is a check which other qualifications, and pretty much any qualification you could come up with is on there.
So I have participated in a maths competition, but not done too well. Like getting a bronze award. I think bronze award's pretty good, isn't it? So would it still be beneficial? Absolutely, because look, first of all, bronze is good. Secondly, what does that demonstrate? You didn't have to do that maths competition, right? That is genuine interest in the subject. You've gone out of your way to do more maths. Absolutely put it in.
More maths, good.
More maths, good.
My it's just leaving, sorry. There we are.
So what's the quota for? We don't deal with quotas.
Yeah, we have international students and we have home students, but we make judgments based on who, looking at the whole application.
So is it okay if I only read a couple of chapters of a big book? No. Do you mean it? Well, no. I mean, it's perfectly okay to have read just a couple of chapters in a book that you're finding interesting. Again, if you mention something that you've enjoyed on the personal statement, I'm not going to test you on it. I might just say, I might be interested. You're interested in maths. I'm interested in maths. If you say, I've been looking into the Riemann zeta function, I'll go, oh, really? Great. What do you find interesting about it? I'm not going to go and prove the Lindelof hypothesis for me, because that would be too hard, because nobody can do that. So keep that in mind. Just saying things on the personal statement that demonstrate enthusiasm for the subject is good.
Yeah. I would say, don't say you've read the whole book if you've only read a couple of chapters, though. Be honest.
Yes. Do be honest. What kind of questions should I ask? The interviewer asks whether I have any. So yeah, the question of whether or not we should ask questions at the end. If you have a genuine question to ask, yes. But if you don't,
it's fine.
One thing I would recommend against. So sometimes people come with. We've asked the person lots of questions. Sometimes the interviewer at the end will say, "Can I tell you this puzzle?" You can, but we're not going to sit there and solve it with you because we've got more people to interview. So it's not that we're not interested in the puzzles that you might have for us. It's just that, unfortunately, we don't have that length of time. Does the course vary between colleges, or is it very similar? The course is identical. So the course is provided by the Faculty of Mathematics. All people from all different colleges go to exactly the same lectures. and all people from all different colleges sit exactly the same exams. So the thing that differs from college to college is the supervisions and the supervisors you have. And you've got some excellent supervisors at Homerton. We've got a great bunch. Can you apply for Maths Masters? Oh yeah, absolutely. So apply to, let's say, Part 3 mathematics after being at a great place like Warwick or Imperial. Absolutely. We get lots of people coming from Warwick and Imperial. Does English still matter from your GCSE? No, if you've got a kind of lower than average GCSE score in English, I mean, as long as your level of English is, yes, exactly. We kind of and maths English is very different to kind of literary English. What?
Shall I take the next one? Can you explain the distinction between the summer and winter pools? So the winter pool is looking at applicants and people who, after interview, it is felt that they could receive an offer, and so we look at trying to kind of even out across the colleges. There is also a summer pool. There are actually 2 summer pools. One of those is for students who perhaps narrowly miss, but the college they apply to is full, and so another college could choose to take them, for example. And there's also something called the August reconsideration pool, which is for students who meet certain criteria in terms of widening participation. So you'd be able to kind of look up more information about those if you wanted to, but you really don't. You don't need more information. Those things happen, and if you are eligible to take part, you'll be contacted. Well, I put the link in, but I'll send it again in a second. How to prepare for the Tamua? That's not relevant for us.
Yeah, we don't use that because we've got STEP.
Just because I've got the link up for it as well, I'll put the link in there.
But I'm sure it's very similar. Practice is how I do it.
Yeah. Oh, I've lost my STEP preparation. I have put the link in somewhere. I'll try and find it again. Okay. Do you care that much about work experience? We've kind of answered already.
The Tamua one was just done.
Yeah.
So there's another work experience one.
How would maths from a maths degree compare to maths from a BSc economics degree?
So the on a point of practicality, in an economics degree, you'll need enough mathematics that you can solve the kind of problems that economists need to solve. That's not the same level of mathematics as we do. Ours will be much more advanced because we're not just using mathematics to, let's say, solve problems in economics. We're actually making new mathematics that might hypothetically be used to solve problems we haven't even come across yet. So the mathematics is kind of learning mathematics for mathematics' sake, whereas in an economics degree, I imagine you'd only learn so much maths that you could answer the problems relevant to your degree, which isn't a hugely high level. Is it helpful to show what you've done after your book reading or research? I read a number theory book and it made me study. No, again, and it's no kind of test. If you've read a number theory book, fantastic. I might say, did you enjoy that book? And that would probably be it, and we'd move on to some problems. So yeah, you really don't need to worry too much. Just be honest. So if you've read a book, tell us what you've read. Great.
So I think we've kind of answered the next question. So we look. It's not just the interview performance that makes a decision. It's a holistic judgment of the whole application. But those ideas of, as Anthony talked through, coming in and problem solving, working with new ideas, working with the people who are doing your interview are really great skills to show. This is another one, Kira, I think for you. Is it possible to balance both the course and the nightlife? I think is the question basically.
Yeah. Yeah, I guess social life in general, I might answer that with.
Yeah, sure.
Yeah, very much is. I mean, the terms are short, but you can always stay an extra week. You're always here a few days early. There's also a thing called May Week, which actually is in June after exams. So that's a week where You do a lot of socializing. You can go to May balls, which are big parties. So you can find a balance, but you also have to be prepared that there will be a lot of work, and at times you're going to have to prioritize that ahead of going out at night. But yeah.
I think that's a really helpful answer. Thank you, Kira. I think as a director of studies, one of the things that I say to my students quite a lot is, okay, well, what are the other things you're doing? It's you have to do things outside of your studies, because otherwise you're just not going to study very effectively. And that could be hanging out with friends, it could be taking part in a choir, it could be ice skating. There's, it's whatever works for you. But we are very aware that your work will be better if you are happy and have a somewhat balanced life. I agree with Kira that there is a lot of work that we expect from you as well.
So simply that's what is the biggest mistake you see in a personal statement of maths? So these things don't come up. The worst thing to do is lie. So if you've said that if you said you've read something, and I say very kind of politely, I'm not going to go in depth. I say, oh, it says here, the Gauss-Bonnet theorem. Can you kind of explain that to me? If the person's face then drops off a cliff and they realize, oh my God, I've been scuppered. I mean, that's a horrible start to the interview. It doesn't mean that you're not going to get an offer, but from your perspective, your confidence will have fallen off a cliff. I don't want that to happen. So if you're as honest as possible in the personal statement, those things you don't need to worry about. No, you don't need first class honours to do part 3. So as a rule of thumb, if you're in the top 40%, then usually you'll be allowed to go and do part 3. If you get a first, then it's automatic. But if you get, let's say, a good 2-1, then we can make the case to what's called the permissions committee. I write a nice letter, and if there's room, then you can go along. So it's basically a good 2-1 or above. How does a mathematical content differ from a maths and an engineering degree? Well, of course, in an engineering degree, the mathematics is very practical. You do lots and lots of calculus, lots of linear algebras, maybe some numerics. Whereas mathematics will do some very abstract stuff that doesn't immediately have an application. So you might do things like algebraic topology, category theory, functional analysis. These are very advanced topics in mathematics that I'm sure there is an engineer somewhere that could make use of them, but for the most part, they're not the kind of things that you do in an engineering degree. So the engineering degree is about practicality. What maths do I need? Whereas in the mathematics degree, it's more like what maths do I want to study for the fun of it? And there's loads of maths out there.
Only 2 to go, Anthony. Oh no, 3 to go.
No. What's the difference accepting the MMath program for third-year students, and what is the requirements of the program? So we didn't ask for a first-class degree. The acceptance rates, they vary quite a lot because there's a large variance every year in the number of people who apply. Having said that, we have a similar pool system. So because of this variance, we have to, again, distribute candidates throughout the colleges. So I'd say in Homerton, if you've got a first-class degree and a couple of good references, I'd say in the past few years, maybe half of the candidates got an offer. So around that. But of course, that's a completely different level then, because not many people get a first-class degree in mathematics. So the pool is a different pool of people. Sorry, I've just clicked off the thing.
How is the maths degree assessed? Is it 100% exams? Kira?
In first year, it's 100% exams. In second and third year, it's mainly exams, but you also do coursework called CATAM, which is it is still mainly maths, but there's quite a lot of programming and computing involved. You produce reports on maths problems, and you use programming to help you. And it's also only third year that counts for your final degree. So because it's a tripos, you get 3 separate grades. But when you give like your overall degree class to an employer, you'd give the third year just that. So yeah.
Thank you. Are achievements like Duke of Edinburgh and or musical instruments worthwhile to mention on your personal statement? It's always worth mentioning them. I think you can put them in the qualifications section on your UCAS application if you don't feel you have enough room in your personal statement as well. I'm participating in a Stanford Maths online course which delves into 8 mini modules, and I have to examine it. It's purely online and free course, but I'm scared that by saying I've learned and completed certain topics, I might be asked about a certain part when I may have forgotten lots of it.
That's great. Shows real enthusiasm. You might tell me what you learned, but I've got my set of problems. I'm not going to deviate from them, so it wouldn't be fair if I started asking questions based on a Stanford, presumably university level course, whilst I'm asking everybody else this set of problems. So no, it won't be a quiz on the extra stuff. You'll do the same problems that everyone else is doing.
Yeah. If you have more more questions after this meeting, the appropriate thing would be to contact the admissions office, and then they can pass anything along if that's needed. Does Cambridge have a harder maths course than Oxford, Imperial and Warwick? It's a tricky question to answer. Different people find different things hard.
I think that ours is much broader. So if we use the metric of breadth, then yes, ours is a lot harder. No, of course, they're all very similar. They're all brilliant places to go and study. I've got colleagues at each of them. Basically, go and visit all these places. That's where to judge.
Yeah.
If you really want to be, no, the supercurriculars aren't too much of an issue. We really care about your maths. It's the main force.
That's quite a good point to end on, isn't it? Do really well in maths. Okay. Thank you. This is where it feels really weird because I'm actually only talking to Kira and Anthony, but you're all there too. So thank you for coming along this evening. I hope that that's been useful. The recording minus those first few minutes where I forgot to record it will be available. I don't know how that comes to you, but I believe it will go on the resources page that I've linked to in answer to a number of questions already. If there are any other things that you want to check about, please do contact the admissions office. And if you are thinking about applying next year and you have the opportunity, it is the University Open Days next week on Thursday and Friday. And I'd really encourage you to come and have a look around, meet some people and just get a feeling for the place, really. So yeah, thank you very much. Anthony, I don't know if you want to...
Well, I just everybody watching, if you're at least been interested in mathematics, I wish you all the best in your future. We'd love to have an application from you. Cambridge is a great place, and if you enjoy maths, it'll be great fun. So thank you very much for listening to me babble on about needles and speedboats.
Thank you, Anthony. And thank you very much, Kira, for giving up your time when really I'm sure you'd like to be relaxing after the end of your course, but we really appreciate you coming along, so thank you. Okay. Thank you so much. I shall end the call.